All right, so here's another attempt, hopefully a better attempt at the simulation we were trying to do in class. First of all, I'm going to pick 6 random numbers to simulate the selection of the 6 students at random. And for the first random number chosen, I'm going to say if the random number is, so that's in A1, if the first random number is less than 10/24, then let's say A. Or maybe we can say D for day shift. So we're told in the problem that there's 24 workers to choose from and 10 of them are day shift. So 10 out of 24, if we're less than 10 out of 24, that will represent one of the day shift people. Otherwise, if it's not less than 10 over 24, but it's less than 18 over 24, then, let me put another if here. If it's less than 18 over 24, then we will say swing shift. And if that fails, then we will say graveyard. End that like that. I got one too many parentheses, but so the reason for the 18 out of 24 is that there's 10 day shift and 8 swing shift. So if it's not less than 10 out of 24, but it is less than 18 out of 24, then that little chunk of the interval from 0 to 1 will correspond to swing shift. And if both of those fail, then it's greater than 18 out of 24, and that'll correspond to the grave shift because there's only 6 of the 24 that are grave shift. So we want to kind of do that same thing here with one problem or one alteration. And that is we need to take into account what happened on the first draw. So, and because one of the workers has already been selected, we don't want the denominator to be 24, we want it to be 23. Now, rather than typing in 23, I'm going to put parentheses around the 24, and I'm going to say 24 minus count if G1 through G1, and then quote not equal to quote. And then I have to end the parentheses on that count if. So that's going to make my denominator 23, just to show you over here. Let me copy this and put it down here. So that not equal to notation, for whatever reason, that counts just the total number of cells. So, but not only that, I don't want it to be 10 out of 23. I feel like the 10 should be reduced. If we're going to call this a day shift person, the 10 that are on day shift should be reduced by the number of day shift people that we have seen before the selection is made. So that's going to be count if G1 through G1 is a day shift. So, and a parenthesis to end that count. So we started off with 10 day shift, but we're going to subtract the number of day shift that we've seen before this point, which is only G1 through G1. And then we need to do both of those things similarly in the other problem, in the other if statements. So instead of just dividing by 24, we're going to divide by this quantity here, 24 minus the count if. And instead of just doing, let me move over here a little bit, instead of just doing 18 over 23, we need to reduce that 18 in 2 ways. So let me copy what I have over here for this less than. So in place of this 18, we're going to say 18 minus this, just making sure we have no errors there. So I want to subtract from 18 the number of D's that we've seen before here, even though I'm making the decision on S right now, because so we've reduced the total number to 23. If we have not seen any day shift or any swing shift, then swing shift still represents the 11th through 18th person. But if we have seen a day shift, then swing is not going to be the 11th through the 18th person, but it's going to be the 10th through the 17th person. So we need to reduce 18 by the number of day shifts we've already seen. And in addition to that, we need to reduce it by the number of swing shifts that we've already seen. So this is helping us figure out these, I guess you could say, conditional probabilities. And then I would love to copy and paste this formula 4 more times for the other 4 selections, but I need to make sure that these formulas are going to move the way I want it to move. So I want this formula to always start at G1, but in subsequent columns it could end at H1 or it could end at I1. So I'm going to leave that second part alone. And I want this one to always start at G, and I want this one to always start at G. Basically, I want all of these to always start at G, but I don't want them to always end at G. So now if I copy, paste, 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 there's our 6 workers selected at random. And let me copy that and do that a whole bunch of times. And then, like we were talking about before, we're going to count among G1 through L1. We're going to count the number of day shift that we have. Sorry, let's see. We're going to count the number of day shift that we have. And we're going to multiply that by the number of swing shift we have. And we're going to multiply that by the number of graveyard we have. And if that product is ever 0, then we know that one of the shifts is missing. In this case, we got all swing and day and no graveyard. And so then over here, let me shorten up, let me zoom out just a little bit. Over here, we are just going to count from M1 through M10,000, count the number of zeros. And let's go ahead and paste this all the way down to 10,000. So we're going to count the number of zeros up to row 10,000, and then we're going to take that number of zeros and divide by 10,000, and there's our probability. And as you recall from the answer key, the probability is supposed to be 218. But this is just a lesson in the fact that 10,000 is not really the long run yet. So let's try to go up to 100,000. And let's add 1 0 there and paste. So hopefully that won't take too long to randomize. Still got a little bit of a blue circle. The paste was done, but the updating the randomization is not complete. Okay, there we go. So now let's look at how many zeros we have up to 100,000. And then let's divide that by 100,000. And now we'll see, every time I redo the 100,000 simulations, now we're going to see answers that are much more consistently around the 0.218 area. So the main problem with the simulation before is that it was not taking into account what happened on the previous trials. So that's what the simulation should have looked like. I suppose I could try going to 1,000,000, but I'm not hopeful that the copy and paste will work, but I'll try it just for jollies. Copy all of that, go down to line 1,000,000, and paste. Let's see how long that takes. The progress bar at the bottom is encouraging, but even after the progress bar is done, it will fill with all of the paste, but it won't necessarily redo the randomization. So I don't know if this is too much for the memory of the computer. So there, the paste is done, but now it's going to take a while to actually redo all those randomizations. So we're doing 6 random numbers on each line, and then we have, I guess, a combination of 12 if statements on each line, and we got 1,000,000 lines. So that's being done quite a bit. I'm not really sure how long it'll take this to update, or I might just have to end the recording here. Maybe I'll fast forward to when the paste is done. Okay, that took more than 10 minutes. You can see how my time changed down here on the clock, but the randomization is done now 1,000,000 times. And you see, oh, I need to change this to go up to row 1,000,000. Oh Lord, now it's got to do all the randomizations over again because I changed something. As soon as you type, there we go, and then over here, divide by 1,000,000. Every time I type something in a cell, the whole randomization regenerates. So as you can see, we're getting estimated probabilities via simulation that are pretty consistently in the ballpark of 218. Even 1,000,000 simulations, it seems, is not quite the long run yet. But if we were looking at 3 decimal places, every one of these simulations so far, it rounds off to 0.218 for a probability. So anyways, there's a better run simulation for you. I'm sure if we did this in some programming language instead of Excel, we could have done the 1,000,000 simulations much more quickly. But anyways, like I said, all of these are rounding off to 0.218, so I'm pretty confident that this simulation is working well. All right, that's it.